So last but not least, they say, at the very beginning, if you match what it reads on the agenda with the title of my talk with what you see here, there's this little diff of the word experiments missing. And so, believe me, I handed in the talk with this title. Then the UI5 people, yeah, so then, okay, we'll finger point. So then Margot approached me and said, the title doesn't fit on the tile. You need to shorten it on the agenda tile. So they took away experiments, which is fine with me, but just in order to set expectations right, yeah? This is not the super effective guide on augmented reality in UI5. This is experiments, what they look like, I'll show. What I took out of them, I'll tell you and you'll see, but this is not a guide of any sort, yeah? So having said that straight, you need to endure the marketing slide. So this is the company I work for, we're doing blah, 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 I do the other, okay, let's start. The whole idea of the talk originated in a customer project, which was, it's a manufacturer of sanitary equipment. So they produce mainly faucets, shower stalls, shower heads. And when they sell them to resellers, so sanitary installation companies, then every once in a while the field workers head out and they take stock. So what does this installation company actually exhibit in their house, site, whatever, of the products that we've sold to them? And up to that point, there was the field force walking up with a laptop, looking at things, and then typing it in, you know, SAP GUI and everything else. And one of the process managers thought, I think we should be able to speed this up. So what they did is they approached us and said, can you come up with a way to accelerate things? And then there was an RFID solution tested, which is not so cool because RFID tags look ugly on faucets. And finally, we had the idea, okay, why don't we, if we have all the reference images of faucets, of shower heads, whatsoever, and if we could actually take pictures on site, wouldn't it be possible to match the pattern with the picture? And to top things off, they're out there in the boonies, so not everywhere you have a big internet connection available. So another prerequisite was make this offline and make it run on the client only. So no machine-based learning, AI, pattern, whatever, SAP cloud thing. It had to run on the device. Now, in order to do that, it's basically, so in order to match a pattern with a picture, you have to do a two-step process. And before we go into the tech details, how it's done with UI5, I'll simply show it. So for that, I'm going to start a UI5 application that you're going to see for the rest of the presentation too. It's going to run once in the browser, then it's going to run on an Android phone, then it's going to run with Cordova browser encapsulated. Reason being is it's really easy to use the camera plugin in Cordova. And I didn't want to write different code for every time, so it was sort of lazy thing. That's why I stuck doing this. Now, this is the Cordova version, and this is the browser-based version running. So the theory behind how you actually manipulate a picture at runtime client-side is if I take the picture, I know the old UI5 icon, but hey, you know. And then you can invert it, you can grayscale it, and manipulate it in any shape or form client-side. So that's entirely possible. You can also do the same if you grab the webcam. So that's me. I'll capture the picture. So it's there. And then I can also invert colors there. I can grayscale things. And especially the grayscaling part is going to be really, really important for all the following steps. Yeah? So how is this done? It's always an HTML canvas. It's always the context of that canvas, and it's always some base64 that comes from that canvas. And to get even into more tech detail, this is a code excerpt how it looks like. And yes, it's promises. It's one of my favorite topics. I like promises. For those of you who do not know what promises are, they're, in a nutshell, a really cool way or a really effective way of keeping control of asynchronous sequences. So instead of having to register callbacks all over the place, you'd use promises, and then you can sequentially do one thing after the other without losing or locking up any UI. So this is a promise example here, and it starts essentially with, hey, give me the picture from the live cam, as you've seen right now, navigate to get picture. Then this returns the picture as a base64 string representation. And with this representation, you can actually manipulate the string. And after that, you grab whatever element of the UI5 page you want, and you set source with the modified base64 string. And of course, never forget the catch clause, yeah, little excerpt to promises. Many people do all the time. It's very hard to debug without. So what does this promisified and manipulated image promise look like? Also a little source code again. Essentially what you do is you wrap the image onload function with a promise. So you see here, it registers a new image. It sets the base64 string that was retrieved by the webcam or whatever base64 string you have to the image. And then the code says whenever you have finished loading that image, so the DOM representation of the image, then context, draw another image on the context, give me the data from the context, and then the actual manipulation happens here. So you iterate actually over every single pixel of the picture, you change the pixel, and then you take the result and put it back onto the image itself. And after you've put it back, you resolve the promise, and with every MIME type and so on and so forth. This is in the details. Now, okay. So you've got the image manipulated for the entire image pattern recognition process. Now, next step, of course, is how do you match it? And for that, I have an example. So imagine the needle here is some sort of a faucet, and down there you have the picture of the showroom. And now what you, in theory, of course, want to do is you want to collect whatever faucets are visible on the picture, and you want to take stock. And I'll do this now with this picture here because it's a lot more colorful, so it makes a lot more sense to present and show. I'll push find needle in haystack. And what you see here is a visualization of the algorithm. So you actually see, represented by the colored lines, what the dumb machine has determined to be a pixel match. So on the top left, you see the little fishy, and it was recognized on the far right side. Looks pretty promising, right? But if you take a sharp look, of course, doesn't even have to be that sharp, you also see they were pixel matched, represented by these colors here. You can see my mouse, right? Yeah. Represented by these colored lines here that are obviously negative matches, so false positives. And you can also see that there's multiple of those little goldfishes on the picture, but the match only caught one. And we'll get to that in a second. How was it done? I didn't implement any of this myself. Way too complicated, because that's the part where we get into math. And computer vision math, you know, it's been a couple of years out of university, and even then, I'm not so sure. Anyway, so there's two cool libraries called JSFeed and Tracking.js. And they've they contain reference implementations of computer vision algorithms, I'd say. They're freely available in the sense of they're open source. And for that particular example, so runtime client side, what we've done is, first we've put the Gaussian blur filter on top of the needle, and we've grayscaled both the needle and the haystack. Why did we do this? Gaussian blur, most of you might know from Photoshop, yeah, if you want to make your selfie look a little better, yeah, then you blur some outlines and then all of a sudden the skin looks smooth and everything. So that's the same that we do here. We blur it and then we grayscale it, and these two things together reduce noise in the picture. So it gets a lot more easy for the fast algorithm to detect corners. That's the next step. And after you've detected the corners, the following two algorithms, both brief or orb, or end or orb, then do the actual pattern matching. And without going into too much detail, what happens behind the scenes is they're calculating binary strings of both the needle and the haystack, and they match these. If the strings are the same, they say, okay, I found that pixel from the needle in the haystack. What went fine, what went wrong? So you might have thought, okay, scale, so size of the needle, and rotation, perspective of the needle might be an issue. They're not, funnily enough. So you can really, I'd say, to a very high double-digit percentage, be scale invariant and rotation invariant. But what you cannot do is determine what matches are positives and false positives. So that's the first problem. You cannot say this is a 90% match. You get your matches and you have to believe they're matches. It's the dumb algorithm after all, yeah? Then also, what I wasn't able to achieve, which does not mean that it's not possible, but I couldn't do it, is provide multiple iterations of the needle to find in the haystack. I could only do it once. I didn't find a way to exclude that area of the picture and then iterate over the rest of the picture in order to find the needle again. So multiple matches were a real issue, or are a real issue. And then moving back into the original business idea, so sanitary installation company, there's shiny surfaces, there's mirrors in bathrooms, and there's of course reflections all over the place. So it happened in some of the beta tests that the faucets were found from another showroom reflected in the mirror of this showroom. So, I mean, bottom line, business case over, yeah? So client side, pattern matching, no way, couldn't do it. Still, at that time, that idea already took on a life of its own, I'd say. Because, you know, you're so deep into things, you play around, you feel like, okay, you get a grasp on computer algorithms, and then ideas start to expand. So what actually happened was, couldn't you do something still with when you have the images, when you try to match them, and on top of sorts? So the idea came up like this. You have the reference object. Let's take the faucet again. You match that object, let's say just once, by walking into the showroom, and you're right on top of it, yeah? So you know this is going to be for sure a match, because there's no other faucet in the picture. Then, if you take the picture, you can record the geo-coordinates, right? Where you're currently at. Also, of course, you know the timestamp. So what prevents you from recording this in a total, storing it, and then make it pullable at any time later again? So I'll do this in live. And I'll explain what this AR push-based scenario was about later on too. So I hope this will work stable. Now, you see there's this little app also as a hybrid app displayed here. And what I'm now going to record is several of those things that I just mentioned. So I'll start with Peter.
Should I smile? Or?
No need to.
Angry.
So let's start Peter. So imagine yourself being the faucet, yeah?
Okay. Let's see what you do with me.
Come. So yeah, very good demo. Let's try that again. It must be you as the motive, Peter. So, okay, you could also see that I've got these little Cheeto input boxes on the right, and we'll come to that later. This is for demonstration purposes, yeah, and also for something I'll explain later. So imagine I've recorded the faucet at a certain geo-coordinate at a certain point in time. Now I'll send this off. This is sent off to my laptop where a little geo-based mock-up kind of a server runs. So it's a little node script that takes those things, stores them, and then you can call them later. Now let's do another person here. Would you volunteer? So I'll record somebody again. I'll take different coordinates now. I'll send this off too. And I'll take you three. Okay. And I'll send this off too. So I've collected my faucets, my shower heads, whatever. Now imagine time goes by. At some point, Jesus, wasn't me. The field worker comes back and wants to see what did this showroom look like at the time when I recorded it, in order to compare how does it look now. So from a technology perspective, how this is done, you have the API Navigator watch position. It's part of the native implementations in browsers. And that issues, whenever you change position, a new set of coordinates. So I walk on, the watch position pushes me the new position. I walk on, so on and so forth. Now, in the UI5 context, of course, I can react to events, right? So I take this event, and I process it. And first, I can, of course, say, now I've got recorded timestamps. And let's have a look, or let's select the first recorded timestamp. See up here? Oh, you can't see? Sorry. So I've, on the top, there's this slider thing that represents my point in time. I'll push this a little to the right so you can see the slides. So I've selected a point in time, a recorded timestamp. And then, on retrieving or receiving the new coordinates, I can, of course, say, does that object, so one of my faucets here, exist at that point, at that geo-coordinate? If yes, I can blend in that object at that point in time. So let's try this. I'm walking over, let's say, oh, Jesus. Let's say watch position fired right, yeah? And you can also say, see with your sharp eye, I got this little Cheeto thing on the bottom of the screen as well. So I walk over again here, I'm at the same latitude, longitude, I inject this, and you see, oh, a little green gluey. And if I now turn around, oh, look, there's Peter there, the little faucet. Now you can also see, of course, ideally, yeah, it would show me Peter at this position. And I'll tell you why it doesn't work a little later on. Now, if I'm at the wrong coordinates, so just to prove this is actually working, see that little red glowing means, okay, no image at that position. See, Peter is gone. Then I'll run over to the 3 guys just to prove the point. So I select a different point in time at the very top. That's my 3rd image I took, so June 5th, 2017, and so on and so forth. I remember, or watch position gives me these coordinates. And all of a sudden, ooh, there they are again. So if you were to be a little philosophical, you could say we've bound time to a UI5 control, yeah, the slider up there. And we also bound space to a UI5 control, right? Which is this. Okay, how is this done? It's RJS, publicly available framework that blends in images over live camera feeds. Live camera feeds meaning the WebRTC framework, and we'll come to that later in the following slide. Because it's cool to show, yeah, but there's many, many, many issues with this. So the entire Navigator framework or API implementation in the browsers is not accurate enough. Meaning, even if you get the very best positioning in lifetime, it's up to a meter. But if I really want to identify things at the exact spot where I am, this is a question of centimeters. So there's actually no accuracy right there. And what's even worse, you might have seen that I do not have a SIM card in that phone here. The API get current position to retrieve the actual geo-coordinates works really well on GPRS networks. If you have a SIM card in there and you're hooked up to the mobile network, it doesn't work at all on the wireless LAN. It gives you the position every once in a while, and that's it. So absolutely not dependable. And the heading that you get from there, so meaning how I position my phone, west, north, east, and so on and so forth, also not reliable. It gives you sometimes that one direction, sometimes the other. So that was the reason I took the picture of the people heading up to them, so I would expect if I call them back in to be at the same position. Just doesn't work accurate enough. And you know, after going through this, then I accidentally called up Google Maps, and all of a sudden, so I can do that actually right now, and you'll see. So I called up Google Maps in order to, you know, show how or see how they do it, and all of a sudden, yeah, I know. Hold on. And all of a sudden I see, I hope it's updating fast enough in real time, the heading tracking actually works really well. And if I walk around, you might not see this because the space is not large enough here, but this works too. So I'm wondering, hey, there must be some tracking mechanism in place by the Google folks that does not solely rely on the device. Know what I'm saying? So yeah, Big Brother is watching you, gets an entirely different perspective from this. Because based on the experiences, I would expect the tracking to not work at all, but obviously it does, yeah. So the remark was position sensors might be, never investigated that, so I can't really say. Also, then just my fault, so to speak. Another issue is, as I said, you'd have to be, in order to be really accurate, you'd have to calculate the perspective as well. So whether I kneel or whether I stand, whether I bow over or whether I bow up, in order to take the picture, I'd have to calculate that angle too. And I never got around doing that. So that was another thing that prevented the geospatial time machine, yeah, of working properly. And then, of course, the framework that I used, so RJS in combination with UI5, it wasn't just a piece of cake and you'd say, yeah, of course, let's do it. Here's the object, update, and this is the picture. So the framework is not a framework. There's a lot of manual coding to do, a lot of twisting left and right. So it's not a framework that you'd be able to use. And I have not come across one that would be. So that's another issue that prevents me from, in the web medium, so to speak, with UI5 or not, to use that. But, of course, as I said, this thing had taken on a life of its own. So we were thinking, or I was thinking, okay, you got the image manipulation down, works pretty well. You got the pattern matching down of some sort, works pretty well as well. Why can't you go one step further and see if this can be applied in the other direction at real time, so not tracking things that are around in the room or at geocoordinates, but tracking myself and influencing my environment, right? So the bottom line is track movement across devices and project target object. So one after the other. What you can do is you can manipulate the webcam picture in real time. So this is me here, right? You recognize me? And this is nothing else, in essence, than the Gaussian blur, again, grayscale, again, edge detection, again, but not on a static picture, but on the webcam feed. And now that there are edges, what prevents me from tracking those edges? So look. See this little green ball that I can stick to my head? And take it away again. See, the bad part is this isn't actually the presentation, it's just the side effect. Yeah? So, anyway.
Was it recorded before?
No, I can do it again if you like. Here, stick it on top of my head. I'll walk around with it, leave it there. And then take it and push it out. So I'll explain the tech details behind this a little later. What I'd first like to show is, okay, I can track the edge of a movement now with those computer vision algorithms. I can, of course, also track 2 points, right? If I can track 1, why can't I track 2? And if I can track them, I can also calculate things in real time, right? So what would happen if I'd actually calculate things and apply it in real time on an image, for example? And, you know, in every direction. And, okay, cool. Now I need to take a little preparation break right here, because we were thinking, okay, now that you've got the tracking and the detection down, you could also spread this across devices, right? I mean, what keeps you from that? So I'll turn on the video feed here, so you can actually see things that I'll do right here. So this takes a little second. Okay, with my travel toothbrush and the UI5 sticker that we just all got. So I'll turn on the camera. The right one. So, okay. Somebody sing something or anything so I can actually do this a lot faster. Need to grab the next phone. Okay, I'd like to talk about something, but there's nothing to talk about. So you simply have to look and see me doing things. So this is again the same UI5 application that you've already seen. Yeah, you can't see it yet. You might be able to see it if I look at here. So let's do it a little this way. Okay, so as I said, so we have tracked the motion. Now, what keeps me then from sending this picture over to the other device? See that? So what this is, because you're so far away, you can't see this. Is why I set up everything here. This is projected into this little hologram device here. Yeah. And at runtime, and when I now track the motion, and so first I'll settle this, 1 point, 2 point. Then I'll say, okay, a little magic thing. Wait, let's make this better. So. Now again, track my motion to the device. And then give it back to the desktop. Or again, to the device. So this is the little hologram changing size and shape, and of course, you know, the nose thing. So this is then computer vision basically applied, motion tracking applied, UI5 context, sent from device and back in real time. You want to know how it's done? Or finish now and be awed forever? Okay, so a WebSocket is the answer, of course. So there's a direct WebSocket connection between the phone over there and the computer over here. And this is, of course, always open, so I can send information back and forth. That's the first thing. The second thing is, I already mentioned, I have a grayscaled image. I put a blur over it. I apply the so-called canny edge detection algorithm. And then the magic lies in the Lucas-Canade motion tracking algorithm. This is what, you know, kept the little green points moving. And then, very briefly abstracted is, Navigator get user media gets me the camera feed. I'll take the camera feed, I apply all those filters, I throw it onto a canvas. From the canvas, I request the animation frame, and I project this animation frame onto another device or onto my desktop. And all of a sudden, I can manipulate things in real time. And I think the true magic lies in transferring binary data from device to device. So how this is done very briefly is, again, canvas, give me all the pixels. Then, see this, JSON stringify the pixel data, send it over. The receiver takes this data, parses it, and if you've paid very well attention in DJ's functional programming hands-on, you see there's a map function here that takes on the pixels and then actually writes them on whatever canvas there is to write to. The reason I had to hurry up is on mobile, WebSockets close real fast. So if I had if I were to awe you now, it probably wouldn't work anymore. But of course, I'm not going to spoil the effect, so I'm not going to do it again. And the projection itself is done differently. Even though this looks cool with the hologram, of course, it's all fake. You know, this is just a little pyramid with some plastic casing. And I hope you can see that. The projection itself, oh, I can actually, right? I can actually show you the 4 images here. So it's 4 images, and if you have a certain angle in projection applied to them, then this all looks like a real-time hologram. But it's only 4 pictures rotated clockwise. Yeah, boo, not so interesting. And in regard to the UI5 context, what you can do is you can bind events or controls to the messages received from the WebSocket. There's a UI5 specific WebSocket implementation in the framework, so you can use that straight away. And of course, what you can't get is my own special crafted hologram device. You have to build yourself one. So getting a little more serious again, we got 4 areas. Essentially, we have image manipulation, we have pattern matching, we have augmented reality of sorts, and we have extended desktop, so to speak, or extended whatever across devices. How does that add up to? So in my point of view, I've mentioned canvas and context several times. The integration of these in UI5 is really easy, because all you do is you put the HTML itself with a generic HTML control into the DOM. And from there on, it's all math. Yeah, as I said, the Gaussian blur, the edge detection. But there's libraries that take care of this. And of course, with the help of promises, you can control the rendering or the manipulation or the different states of images, so on and so forth. So from my point of view, at least the manipulation part is rock solid, and you can use it anytime in production. There's no catches to it. So you can do your little Photoshop client side. The whole ARify thing of time and space is a really nice idea, with a philosophical thing saying, okay, I can bind time and space to UI5 controls, whatever. Important to notice, this all works with HTTPS only. So getting the live web feed, the live webcam feed is only allowed in browsers that support the WebRTC framework if you serve the page via HTTPS. And the entire WebRTC, and with it, its navigator.get user media implementation is only available from iOS 11 on, and is not available in IE at all, but is available in Edge. Still, this cuts out a significant share of the market, so you for sure can't say that it's by any means ready for generic production, I'd say. And add to this the insufficient tooling that I've mentioned. It's very pesky to handle it. It's a playground only. It's a nice idea to have it client-side, software-side only, but it's a playground only. And then extending your usability to the mobile medium. Event binding works with WebSockets from UI5, really cool. You can rotate canvases, display images in any form or shape by using intermediate images that you've seen right now, the 4 times clockwise rotated. A little drop in the eye is that you'd have to avoid the UI5 lifecycle there to avoid re-rendering issues. So I did it in the beginning with using the native image from the sap.m library. This wasn't smooth enough, yeah? It's just the browser rendering engine isn't quick enough to update itself for that. So sidestep going directly to the DOM and manipulating things there. And from my point of view, it was really fun developing this, but it's nonsense in essence, yeah? I mean, yeah, okay, cool. Hologram, resize it, fine, but what can you actually do with it? So some of you might have an idea where to take this, I don't. And At some point, I'll publish this for sure, the source code in some GitHub repository so you can play around it with yourself. The setup is really specific, so with a laptop, and it will not work out of the box, let's put it this way. So thanks for listening.